Okay, my friends, let's take a look at this matching birthdays quiz and get some solutions for it. So what I did was I kind of simulated the idea of having a bunch of people in a room and randomly generating birthdays. So I'm going to go ahead and open this spreadsheet like it tells me to. Hopefully it works while I'm recording this video. Is it? Oh, that looked like it worked. Okay, here we go. And it looks like it opened in a web page. Hopefully this works. We'll find out. All right, that looks pretty good. Let's see if the randomizer works. Okay, it does. Very good, very good. Okay, so we're going to change it to 19 people in the room. Edit a copy. Oh, for God's sake. All right, hang on. I'll just open it locally. Give me 1 sec. Sorry about this. I don't spend a great deal of time editing the quiz solution videos. Hopefully you understand it takes forever to edit all the other ones, and these are just kind of seat of the pants. All right, there you go. 19 people. All right. So in the video, you saw me do 10 trials where there were 2 matches and 8 not. Now I'm going to do 10 more trials. So I got 1. I'm going to write this down so I can keep track. Yes. No. Okay, so I got a yes. All right, let's re-randomize it again. I got a no. I got another yes. I got another no. I got another yes. I got another no. This is fun. Yes. Yes again. A no. And a yes. So I got 6 yeses and 4 no's. That's cool. All right. So let's see what we got here. 10 more trials and combine them. So if I have 6 yeses and then 2 more, that would have been 8 yeses out of all 20 trials. So that right there, my friends, is 40%. So right now, there's a 40% chance of getting at least 1 birthday match if I do 8 out of 20. I said, let's do 30 more trials. All right, so 30 more trials altogether. Let's go back to the spreadsheet. All right, so I'm going to do yeses and nos again. Let's keep track of them. All right, so I got a yes. I got a no. Just a little bit more logically on my paper here. All right, yes, no. 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 5. Yes. Yes. No. Yes. Yes. That's 10. No. No. Yes. No. 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 Yes. What's that up to? 7. That's 10. That's 17. No. 18. Yes. 19. 20. Wow. Among these 30, it's 50-50 right now. That's kind of wild. Yes. No. Man, it's like neck and neck. This is fun. No, 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 no. Okay, I spoke too soon. No. No. Yes. 2 more. No. No. All right. So I've got, of the 30 I just did, I have an additional 12 yeses. So that's 8 plus 12. Is going to be, oops, just lost my eraser. 8 and my lead. My goodness, I'm having all kinds of technicals over here, y'all. 8 plus 12 is 20 total out of 50 trials. So that still slots right in at 40%. If I did the 30 more, if I did this correct, let me check the math, make sure I did it correctly. So the total is going to be 50. I had 8 yeses originally. I picked up 12 more. That's 20. Yeah, so 20 out of 50 is 40% yes. All right, so let's go back to here. Rewrite that last percentage as a fraction. That's actually a little bit tricky with 40% because it would be 1 out of 2.5. So it's a little bit bigger. It's a little bit bigger than 1 in 3. So yeah, it depends. And honestly, number 3 is going to depend on what you got in numbers 1 and 2. So 40% is 2/5, which is the same as 1 out of 2.5. And then number 4, the answer to that is it a rare event? Well, no, because it's going to happen more often than 1 out of every 3 times. I mean, 1 out of 3 times isn't even rare. That's like picking up a die, rolling it, and freaking out because you got a 5 or a 6. Well, I mean, that happens all the time. It happens 1/3 of the time. This is even more likely according to our results we just got. So, no, it's not rad and unexpected at all. It's actually, it was rad and unexpected for us, because we hadn't analyzed it, right? That's what's kind of cool about statistics. We hadn't looked at the data that we just looked at. We just had an event. It seemed counterintuitive. And then upon closer inspection, it really isn't. All right. How many people do you think need to be in the room for there to be about a 50% chance that there's a birthday match somewhere? And I really, honestly, I can't answer this question because I'd have to know what you said to do this question or a number 6. And then number 7 is the same way. So these questions 5, 6, and 7 really just, they really depend on what you put. Okay. Now the goods, this is the second tab. This was where you were actually checking in the spreadsheet for how many people do you have to have in the room to have the probability be a certain number. So I asked you for a 50% shot, and look at that. It's 50.6, and it's just about 23 people, which is crazy. I mean, remember we just did 19, right? 19, I just estimated it at 40%. Well, look at that. It's exactly 38%, 37.8%. That's hella close to 40%, which means it's not rare at all. But it only takes a couple more people in the room, and it goes to 50-50, which is extraordinarily counterintuitive. And then the last question on the quiz is how many people would you have a 90% shot? And that looks to be about 41 people. You're almost at exactly 90%. So I love this. I love that it came up in class. I love that we decided to chase it down, and it makes for a fun kind of surprising quiz. All right. Hope that helped.